Welcome, my dear students, to another week of chemistry with Mr. Miguel. This week we will be looking at the physical characteristics of the states of matter. The objectives for this week are the following. However, we will start with identifying the states of matter. So let's go and identify the states of matter. As you can see in this slide, there are three states of matter that we are concerned with. The first is solid, the second is liquid, and the third is gas. And we will be looking at the characteristics of each of these states of matter. Objective number 2 is to differentiate between the states of matter based on their physical characteristics. When we speak about physical characteristics, we are concerned about the physical traits or the properties that a sample piece of matter contains. This means that matter will have certain traits that identify it and make it special. Take, for example, Mr. Miguel. What are some traits on his face? The first thing, or the first characteristic that you can identify is that Mr. Miguel is fair-skinned. That means he is white. He also has yellow-greenish eyes. He has black hair. And those are traits that we can readily observe on Mr. Miguel. So when we talk about the states of matter, we are referring to the characteristics that we are able to observe, whether with our eyes, our ears, with our hands, but we can take measurement of it. There are various properties that we talk about. It starts with shape, ending with the arrangement of particles. And if you want to know the list of properties, just look at the slide below. So let us look at the physical characteristic, shape and volume. I would read this entire slide, but I think this example would make a better choice. What are you able to see on this slide? In the first slide, you're able to see a cube, which is a solid. Is the shape constant? Yes. That means if I grab that cube and I put it on the table, that cube will continue being a cube. It will not change. So when we talk about the shape of matter, or the shape of substances, or the shape of the states of matter, you have to know that solids will not change. The shape will not change. Liquids, on the other hand, if you put the liquid in an Erlenmeyer flask, like shown here, you're able to see that the liquid assumes the shape of the container, and the same is true with gas. Let's talk about volume now. If I put this cube inside of this Erlenmeyer flask, does the volume change? First of all, what is volume? Volume is the space a sample substance occupies. And in this case, we're able to see that solids retain the same volume. Liquids, do they retain the same volume? Let me give you this example. Let us say that this substance, look at this slide, and this sample volume is 100 ml. If I decide to dispose of the contents or this sample matter, and I put it inside of a cup because I'm gonna drink it, will I be drinking 100 ml? The answer is yes. It is most likely that you will be drinking 100 ml. So what can we conclude from this? We can conclude that the volume of liquids does not change. Now let's look at gases. Gases, on the other hand, if I decide that I will put this gas inside of a room, the gas will disperse. Once it disperses, it will assume the shape of the room. What if I decide to collect this gas and put it in my gas cylinder? I can make it fit in my gas cylinder and it will assume the shape and the volume of the cylinder. Now, what if I want to compress this gas? That means that I want to make it smaller and put it inside of a little lighter. Can I do that? Yes. So what we see with gases is that they assume the shape of the container and their volume can also change. In summary, what can we learn here? The first thing is that solids have fixed shape and volume. What can we say about liquids? Does it have a fixed shape? So no fixed shape. But constant volume. What about gases? Gases have no fixed or volume. We will refer back to this property later on when we talk about the arrangement of particles. Now let us look at the second physical characteristic. The second physical characteristic is density. Remember the particulate theory of matter? The first tenet of the particulate theory of matter states that all matter is made out of particles. If all things are made out of particles, we can imagine small little dots inside every single substance in the universe. Let us look at the example provided for density. There are 3 squares which you need to observe. But what is density? Density refers to how close particles are to each other in a given space. So density looks at 1, how many particles there are, and 2, what is the volume or what is the space. In this example, we see that a high density would contain a lot of smiley faces. This would be high density. How do we know? Because particles are packed up very close to each other, and the density is high in solids. Let us look at liquids now. How would the density be in liquids? The density of liquids tends to be slightly different than that of solids. In this case, we have particles are arranged close to each other, but are not extremely close to each other. They are close, but not too close. So we have medium distance. So medium density would represent liquids. In the third box, we see that there are even less smiley faces in that given volume. This would represent gas. Because particles are spread out farther from each other in gases, the density is lower, so we have low density. In summary, what can we learn about density? We can practically summarize it in this way. Number of particles in a given space. So how many particles are in a given space? That is density. Let us look at this very strange looking image. We see on this side to the left, we see an elephant, and on the right hand side we're able to see a mouse. How is it possible that even though they are so far apart, they are still able to maintain equilibrium on this seesaw? How can this be possible? Well, I simplified it in this way. Look at the red dots inside of each organism. In this organism, you're able to see that the particles are farther from each other, and because they are farther from each other, they tend to have a lower density. So this one would have lower density. And here in this mouse, we are able to see that the density is high. Even though the volume of the elephant is larger, the density is lower, therefore they both end up weighing the same. In each organism, I added 30 dots, so there was 30 particles. Therefore, they end up being balanced. They weigh the same, they have the same mass, they just have different volumes. Let us look at the third characteristic, and it's compressibility. I want you to imagine this. Compressibility is how much you can press on something to make it smaller. Liquids and solids, if I grab a solid, this means I grab a rock and I try to compress it to the best of my abilities, most likely that rock will not change shape at all. Liquids, can they be compressed? To a very, very minor level, you can compress liquids. So if I grab a liquid and I try to push it, I will or I should be able to compress it a little bit. Compressibility means the degree to which you can make something smaller. Now if I have a gas, gases can be compressed. And gases, if I would grab a gas and let us say I had superpower, I could grab a gas and make it smaller and make it to the size that I want, shrink it to the size I want. So we can see that because particles are so far apart, we can grab a gas and make it very small. In solids, since the particles are so close to each other, they cannot get closer. If you try to get them closer, like in a rock, it will break. Let us look at the image shown on the slide. In this case, we have a gas. And this gas, you are able to see that the particles are far apart from each other. Therefore, because they're far apart from each other, we should, in theory, be able to make those particles come closer together. When we use force to make those particles come together, it is known as compressibility. Let us look at physical characteristic number 4. Energy level of particles. This refers to how much energy you can expect the particles in each of the states of matter to have. Solids, let me pause there. The particulate theory of matter tells us that particles are in constant random motion. So we know that even in solids, these particles are constantly moving. In liquids, these particles are constantly moving. In gases, particles are still constantly moving. There is only a difference, because in solids, the particles are moving, also known as vibrations. So they vibrate and they move, but they move with such low level of energy that you cannot expect the particles to freely go away from each other. This means that in solids, the energy level is very low. As you go and you add heat, the particles start to vibrate faster. And as they vibrate faster, you can directly see that your solid starts melting. Why does it melt? That's because the particles are gaining energy in order for them to become independent from each other and in order for them to overcome the attraction between each other. In gases, we are able to see that the particles have a ton of energy. So energy is the highest in gases. This slide depicts the states of matter and their energy level. So in solid particles, we can see a normal Goku, and that Goku has the base amount of energy. The second Goku, which is Super Saiyan Goku, we're able to see that there is much more energy within the liquid particles. And in the third level, we're able to see that gases have an incredible quantity of energy. So in summary, energy level increases as the state of matter changes. Let's move on to our next physical characteristic, which is arrangement of particles. How are particles arranged in the different states of matter? Well, from what you're able to see, in diagram number 1, we're able to see that the solid particles are very close to each other and they form a pattern. In liquid particles, we're able to see that since the particles are constantly moving, they have more energy, they are able to become more fluid like water, like liquid water. And in gases, since the particles have so much energy, they're able to fly off into the open and become independent of each other. That would be the arrangement of particles in solid, liquid, and gases. We know that particles, from the particulate theory of matter, we know that particles have some level of attraction between them. In this example, I am showing you water molecules. In between water molecules, we are able to see that there are small little attractions between each water molecule. That's why water sticks to each other. That's why water retains its liquid state, because the particles have an attraction between each other. Therefore, they don't fly off independently to their own. In terms of forces of attraction, solids have very strong attraction between particles. That's why they stay together. In solids, the particles are so attracted to each other that they prevent one particle from just leaving. So, very strong attraction. In liquids, we see that there is a level of attraction. It is still strong, but not as strong when compared to solids. In gases, the forces of attractions are lost. This means that each particle becomes independent of the other and flies off into the atmosphere. That is forces of attraction of particles. That is all for today. Thank you very much for your attention. Enjoy the rest of your week.